demonstrate how we can, fit a machine learning model on your data. So I'm going to do that now. We're familiar with how to upload. So this is the data I'm using. So I'm just going to upload that now. Okay, so I've been able to upload my data. You can see. So yeah, I've uploaded my data. Uh, so well, you could just do a quick inspection to see the variables you loaded, how they look like. So for me, the next thing is to now head on to analytics. So you click on analytics, and then so you see select test here. This when you are just testing, doing a statistical test, and then this to fit or build model. And so this is a machine learning. So you click on the machine learning. So on the machine learning module, so there are a lot of things you can do. So I'm going to do a quick like run through of how machine learning is usually done. So when you are fitting machine learning model, there are several things you should consider, which determines the statistical, the machine learning model you should use. So the first thing is, are you doing a classification? Classification is basically when your outcome variable, that is the dependent variable, when it is in categories. For instance, you want to predict smoking. So smoking is yes or no. So it's a categorical variable. Or you want to predict, let's say, Lassa fever. So it's either the person tested positive for Lassa fever or not. So it's in categories, not in numbers. So you do classification. So and these are the list of different machine learning models we have under classification. So there is the logistic regression, there is the decision tree, there is random forest, there is k-nearest neighbor. We have the naive bias, the SVM, and there is the gradient boosting, and then neural network. So, but if your categorical variable, I mean, if the variables that the outcome variable you are using is a continuous variable, for instance, now blood pressure. So if you are looking at, you want to predict systolic blood pressure, for instance, so it's in numbers, or you want to predict weight, or you want to predict height, you see that those ones, they are not in categories, they are in numbers. So you want to do regression. And these are the different machine learning regression model you can fit. So the other one we have here is the survivor. So this one is when you are doing survivor analysis. So we use that when the interest is to predict the time that a particular event will happen. So, for instance, now you want to maybe we have some people who are having certain disease and they are on hospital admission. They want to predict when they are likely to recover. So you do survivor analysis. So that's what this survivor machine learning model is used for. So quickly, I'll go back to classification, and then under classification, we are going to make use of one of these. You can use more than one. In fact, the current practice is what we call ensemble model. Ensemble model is when you fit different models and you now evaluate which one perform best. So, and you can see that. So let me quickly explain all this information that we have here, these features. So the auto tune here, there is what we call hyperparameter. So these are the parameters that that enhances the performance of your model. So for instance, if you machine learning model is not something you just fit and that's all. You have to do different tuning to ensure that you have the best model, because you are looking at developing a tool that you can use to predict something. So there's what we call hyperparameter. hyperparameter tuning, and then we have it automated here. So I have explained assemble. Assemble is when you develop more than two or more models and you want to evaluate which one perform better. Then you can also compare your models. You train and then compare model, train a model and then compare it. So here is where you can do diagnostics. I think this data you have here is the one I have, I've uploaded. So here is where you begin to check the features. You begin to check the results of different models that you fit, and you want to evaluate the performance. So uh, yeah, and then your data quality too. So basically, that's everything you have inside the machine learning module. So we want to build a model. I'm going to do classification, and first of all, I'm going to do what we call logistic regression. So I've selected the logistic regression, and then uh, the outcome variable I have to select. So the outcome variable is a variable that you are predicting and saying, okay, what is the, for example, if I say what's the probability that someone, is likely to have a certain disease. So that disease the person is likely to have is the outcome. So here, let me pick. Okay, I'm going to use smoking. So smoking is either yes or no. Is either the participant is smoking or no. So I want to use certain variables to predict it. So I'm going to use age. I'm going to use gender. I'm going to use well, does it look plausible that you say that weight determines whether someone is smoking? Well, let's try it out. And then you also want to maybe we should choose some sedentary lifestyle to see. Okay, vegetables. So it depends on what you are. Remember that literature should determine the choice of the variables you select. So I've selected some here, and then these are the hyperparameters that I need to see before I need to maybe adjust or do something before doing my prediction. So this software is helping us to do some things that we need to pay attention to. So for instance, the learning rate. So you want to immediately you upload your data. So this module will run through your data and identify which type of data it is, and it's going to advise. So this suggestion here is that your learning rate should be between 0.001 to 0.001, so which is the highest. So, but let me adjust this to say 0.00, maybe 7 learning rate. And then this one is suggesting that, okay, for maximum iteration, try and do between 1,000 to 5,000. That's the suggestion. I'm going to change this to, let me say, 2,500. So the thing is, you keep adjusting, and he's citing references that is suggesting that rate. So then you want to choose the regularization. This one is to help your multicollinearity come out well. So what are we advised? He said is between 0.01 to 0.1. So let me do 0.05. Yeah. So I want to enable probability calibration, and then I would like to do k-fold. So I'm doing 5, or let me do 10 k-fold validation. So validation is like you are doing cross validation. At least when you train your model with maybe 70% of your data, you need to cross validate within the same data set, so that to enhance the performance of your model. Now, I want to train the model. Then you click train here. So it's training. So yeah, it's training the model. Now we have the result. So this is the result of our machine learning model. Now, these are the metrics. So the metrics is saying that the accuracy of this model is 24.8%. This is very poor. Me, I always like something above 80%. The precision is 8.0%. This is also very poor. So the recall is 33.3 and the AUC area. So this one is even very, very poor. So yeah, it several things can cause it. Your data set, the volume of the data, the prevalence of the outcome variable in the data, and then, so let us look at what the cross-validation results looks like. So the first one has a score of 27, and the second cross validation had 2.2. This is a pattern of the different validation it did. So then evaluating which of the validation makes sense. So this one is above average. Z-score is 0.84. And then, well, quite a number of them are above average. Now, so another thing we need to also check here is let's look at the AUC. Well, the AUC is actually 0, so it's not going to give us any results yet. So now let's look at the feature importance. So feature importance are to look at the performance of each of the variables you are using to predict, and these ones are doing quite all right. They are doing well. So what is Quantsage? What is Quantsage advising us to do about the kind of data we're having? Look at it. The first recommendation here is imbalanced classes detected. That is, the data is imbalanced. Consider using oversampling or adjusting class width. So this is a suggestion. Now, model accuracy is below 70%. Consider feature engineering or trying different algorithm. So it's advising us whether we should use a different model to do the the modeling, the machine learning. So precision and recall differ significantly. So this doesn't make sense. So consider adjusting the decision threshold based on your use case. Then the good part of it is that high recall or lower precision. Consider raising the threshold if false positives are costly. So I want to implement those advice, and let's see how our results will turn out to be. Let's see, what do we have now? Okay, still. Okay, so I'm going to do a one model thing. You So after the optimization, I will just go ahead to deploy. But then again, you need to ensure that before you deploy for use, ensure that your metrics are doing well. And then you can always come back to this to get to know whether your metrics are doing well. So maybe I will look for a data that has a good number and okay. Yeah, so okay, so this is the optimized one. The optimized one is still showing a very low accuracy. So the other choice is to go back and change the model we are using. So let's try decision tree if this will come out well. The same set of variables, and then let's leave the hyperparameter same way and see how it's going to perform. I want to train the model now. I'm on decision tree. I'm using a different algorithm now. So you try different algorithm until you get the best performing model. So that's how machine learning model is built. scientifically, or let me say conventionally. So, but the good thing is that this app will keep advising. So look at what we have now. Look at it. The accuracy has increased, and then the precision is now high. The recall is still low, and the AUC is still low. So this is a confusion matrix showing us the different like the prevalent numbers for each of them. So this model also is not the best. We need to uh, keep trying till we get the best performing model. I want to do random forest to see whether this comes out well. I'm training it. So what I'm doing already is what we do under ensemble modeling, where you try different model and then you match the model uh, to deploy um, your your model, to deploy the machine learning model. You try different algorithm. So it's still training. Random forest may take some time. So still training. Okay, let's wait for the random forest model to be completed. A lot of iteration is happening currently.
All right.
Okay, so let's do that again because we can't wait for the random forest to be, completed. To take some time. So let's do logistic regression, machine learning model again, and then we're going to, now deploy it. So again, we upload our data. Once you have your data uploaded, you come to analytics, and then you have machine learning model here. Then you select, because we are doing the logistic regression, you select classification, and then you select logistic regression. So you're going to select your outcome variable. For me, I'm selecting smoking here, which is yes or no, and I'm selecting the features, the predictors. I'm selecting age, gender, weight, uh, physical activity. So the hyperparameters, I may just leave them as they are. I want to do k-fold cross-validation, and I want to enable the probability calibration. So I'm going to hit the train button. So I've trained it. This is my result. Yes, like I said, you have to keep doing different algorithm, doing hyperparameter tuning, which is to tune your model to you get the best performing model. Again, remember you should come to the advice button. To this advice section is going to tell you what you should do to optimize your model. You keep trying till you get the best performing model. So come back to metrics here. So now I want to deploy this model. So deploying it means I want to turn it to a tool that can be used. So there's a link. Uh, so once you deploy, Quantsage is going to generate a link that leads to that model. So I want to open it now. So look at it. So this is the model that we have just built. So meaning that if I put my age, put my gender, my weight, let's say 68, physical activity, let's say sedentary lifestyle, and I hit predict button, it's going to generate results to tell me the probability of smoking. So current probability that this person is. So look at the result. Again, don't forget that your model needs to be, the metrics needs to be the best before you deploy. So look at it. The probability that this person is a current smoker is 0.4%. So the probability that this person is a former smoker is 99.6%. The probability that this person is never is someone who never smoked is 99.6%. So these results are not making sense. Why? Because the machine learning model itself, it is not making sense yet. So we need to tune till we get the best model. So that will be all. And if you, after deploying it, you can copy the link here, share with people, or so whatever you want to do with it. So that will be all for the machine learning model, how to build machine learning model and deploy it on Quantsage. Thank you, everyone. Any question, please? I'm happy to take questions now. Can you hear me,